So, welcome at this KiCad tutorial. I must say I'm also a beginner, so I'm not sure if I'm going to do everything right or everything in the right way. But let me just try to show you what I know. So I'm going to create a new project. Oh, not here. Somewhere else. How do I do that? Steam test project. No. Let me create a new test project. Arduino build. So I'm going to show you just the basic steps at first. So first, before you can build design a circuit board, you first have to define a schematic. So this is the schematic field. It's basically an A4. You can print it as well. And now we're going to add components to it. So we press the A button, and then we get, well, you can choose a component, and we can type here. We want to have the Mega 328, and I think I chose the 328 PPU, which has a PDIP, so it has 28 pins. And I just add it, and I place it somewhere. And if you see here, you have pins VCC, AVCC, and below here is ground. Well, so what we can do now is add another component, for example, LED, generic LED, and we place it somewhere. And add another LED, for example. And what we're going to do now is, in this case, if we have red LEDs, so if we power them with 5 volts, they're going to break, so you need a resistor for that, so we're going to add a resistor. So we press R again, A for add a component, we press R and we have a resistor here. And we just add it here, we can rotate it. So add the resistor here.
How did you rotate? Not with R, obviously? Or?
With R.
Oh, okay, when it's selected, then you have other commands at your disposal. Okay.
And I place another resistor, rotate it, then we add it. So, so you can see here that there are reference names for each component. It says D question mark, and this is going to be the system will number each component to make let each component have a unique name. But we're going to do that a little bit later. So if you press V here, we have some text LED, and well, we can give it a nice name, red LED, for example. We can do the same for this as well, red LED. And for the resistors, we could also give it a value, and here we press V, I would give it a value 220 ohms. And do the same for this one, 220 ohms. Well, you can see that this doesn't print as nice, but we can just pick up the label. It asks us now to clarify what we are selecting now, and I'm choosing the field value now, and I move that a little bit up. And you can see it's still connected to the component. Press enter and we're done. And we're going to do the same for this one. So we press select, move the field value, and we're going to move it up a little bit. And well, we could do the same for the for the
LEDs.
Yeah, LEDs, but let's not go into that. So now we want to power the LED, of course. So what we always need is a VCC. So to denote where the power is coming from, and we need a ground. I'm going to put that below because the ground pins are here. So we do add again, the A from add. We're looking for ground, and we add it. So now we can basically build a circuit. So by picking the wire line, and now we're going to connect the VCC of the board. Let me see, here with the VCC that we just arranged, and then we can add it to the resistor, and then we can connect it. This is not nice, so let's pick this thing up and move it a little bit down. Enter, let's connect it to the LED. And well, and if you want the blink program, you want to blink a LED. This is going to happen on pin 19. So we can pick up this one, and we are already installing the resistor and the LED for pin 19 here. And we're going to connect those as well, just by drawing a line. It's very simple. Now we're going to connect that with ground. So here the ground, we're going to draw let me see. Oh, it's not. Well, so I should zoom in. Yes, that's a line, and then we connect this one to this line. This is a join, so the wires are joined. If they cross and there isn't this dot in it, then they just cross, but otherwise they are joined. And now we can connect the LEDs to ground as well.
Could you introduce a new ground symbol, and that would also be directly okay, or?
I think so. Yeah, could be. So we connect this one as well. Well, and well, we can continue to do so. For example, the pins 9 and 10 need to be connected to a crystal. The crystal needs to be connected to I think 22 picofarad capacitor, and this is essentially what you do when you're creating the schematic. So now we can automatically assign, so this is not a full schema, but let's just continue with this. I think you get the basic idea. So now we can annotate all those components automatically and give it a unique name by pressing this button, I believe. Yeah, annotate schematic components. And we just press annotate. Annotate only or the entire, so yeah, I'm just doing OK. And now you can see that so D1 we have here, and D2 and R1 and R2, everything has now a unique name. Now we can, now that we have annotated and the system knows about each component has a unique name, we can perform the electrical rules check. So we run it, and we get now lots of errors. It tells us that some pins have not been connected. It's a very useful feedback, and it shows you with an arrow which pins haven't been connected. So we can pick the cross here and cross out all those components. And just do that for each. So again, this is not a full Arduino, but just to give you an idea of the actions you have to perform. Cross out each pin.
So in a real design, some pins could be floating, meaning unconnected, and it still would be okay. Right?
Yeah. So, and you can also still connect them in the original. For example, you can connect them to the attachment where you can put shields on, for example. I'm not sure what the name of
Header, female headers.
Yeah, exactly. Clarify the no connects, and I want to delete it. No connects, yes. So we just move on, crossing those out, and there and there. I think I crossed all the components out, and I'm going to run the verifier again. And it says, oh well, pin connected to some other pins, but no pin to drive it. So this is, you basically have to tell KiCad what power and ground is. And you can do that by adding a component again with A. It also says the arrow where you have to do that. So, and now you have to find power flag. And we add power flag here, connected to the VCC. And let me see if I am recording, that's good. And we have to do the same for the ground. So here we're again adding this power flag. Let's rotate it, it's a bit nicer. And we connect it. So we're going to run the verifier. Perform electrical rules check, and now we don't have any errors anymore. So now we're done.
Do you know why it makes this indirection? Let's say with the flags, with the power flags, or not?
I think it just wants to know where the power comes from.
Okay, but there are no other uses you're aware of. And if you know what I mean, I guess you could just say a ground is by default always connected to power flag or something.
I agree, but well, ground can also mean that it measures ground. It's not whether it really is.
You
also
set
basically
a zero potential.
Yeah. So now that we have this, what we can do is run CVPCB to associate components to all the things that we have. So if we press this, it takes a while because it loads a huge library of components. And it's trying to automatically assign components to the schematic that we have. And well, it gives, this is an old version. I haven't seen this with the new version, but we just yes, close, and we have it small screen. So, and it's, you can see here now that for the red LED we don't have a component, but we can. Let me see. I think we can auto assign, also perform automatic. Interesting. I would expect it to automatically recognize the LEDs and everything, but yeah, it doesn't really matter. We can also assign it manually. Oh no, I don't. I understand what's going on. So we have to look up LEDs here. Why doesn't it? Oh wait, I have the filtering turned off. Let me see if I. Yes. So if I turn on filtering now. So if I click on such a thing, it gives me the options for LEDs. So it tries to infer what kind of component you have. So for the red LED, we are just going to choose. I think a 5mm LED is very standard. show this a little bit better. So I'm going to do the same for this one. Resistor, I think, actual, I'm not sure whether this is a right one, but you can click on such a thing and I'll look it up and see whether this is kind of what your, so this is the 2D representation of the component. Maybe I will show the LED as well. So this is a LED of 5 millimeters. Here you have the plus and the minus, or the other way around, I forgot. And so this is essentially the representation, the footprint of a LED on a circuit board.
Do they have a 3D representation also already in that?
Yeah, I think so, but then you have to load another library and it takes forever.
Yeah,
and,
not all components.
So let's assign a resistor. So we want to have a through-hole component, and then let's pick something that looks decent. Let's pick this one. Let's check whether that's kind of okay. This looks to me kind of the resistors that we have here.
One question, this vertical and horizontal, does it mean how it stands? Are you mounted on the board or is it something else?
No, good question. I don't know exactly. Yeah. So I'm going to assign that to that one as well. And well, so it gave us an error that it cannot find the footprint for this one, and I figured this out. So in a new version you have something like that, package, but now we're going to use sockets. And this is where I turned off the filtering. So I think this is just the fact that it's an old version. So I go to sockets. And then we have socket strip. So this is a socket where you can put a 28-pin thing in. We want to have the straight ones of 2 by 14, because we have 28 pins arranged in 14 on the one side and 14 on the other side. So we're going to choose 2 times 14, and with, I believe, a pitch of 2.54 millimeters.
I think that's the breadboard. Or?
Yeah, I think that's what the breadboard.
1/10 of an inch.
1/10 of an inch, indeed. So we're going to assign that. So now we have essentially assigned to each component in the schematic, we assign the footprint. So we can save this and close this. And let me see. What we're going to build now is a netlist. So I'm not exactly sure what it is, but I think it just attaches all the wires to the components. So I just generated it. We'll save it in a file. It's fine. So this is the so we now generated a netlist, and now we get into the next stage of making a circuit board. So now we're going to look at this one, the PCB footprint editor. So this is where you can do the layout. Zoomed in very much. And now we can load this netlist somehow. I forgot how, but let me see. Maybe we first have to make a new footprint for Arduino. Let me see. Okay, so this is where you can really see that see. Load footprint. Oh wait, this is the footprint editor. This is the wrong tool. No, so you can create your own footprints if there is a component of which you, custom component, and there is no existing footprint. You can print your own printed circuit board editor. That is the one that we need. Yes. So this is basically this shows the layout of our tool, and well, you can set the page settings for depending on the size. So we might want to set it to 15 by 15, and now we can press here read netlist, and I'm going to just read the current one that we just created, and well, close it, and now we can see that we have all these components spread out over the board, and now we have to lay them out manually. So we can press M to move such a component, and we're going to choose just something, and we're going to move it, and we're going to do that for everything.
Basically untangle it.
Untangle it indeed. That well. And the wires that you see in between are the connections that should be made between the different components. So I now see that this one has to be connected to that one, so it makes probably sense to move this here. And this is then probably the resistor. It has to be attached to pin 19. So 15, 16, 17, 18, 19, indeed. So we rotate it because that is easier. So let's place this LED here. The resistor here, place the LED here, and it has to connect to either this one or this pin, which will be ground. So we'll just put it here, then we have this other LED that should be connected to that one. So
it is already rather a specific question, but sometimes I guess you're forced to connect, or you're suggested to connect to a certain ground.
Yeah, you know, can,
or yeah,
it doesn't matter. I think if you
in this case, I get
yeah. So let's see if it's connected to. Maybe it's better to place this here and get this. Rotate or move. I mean, this has to be connected to that one. Let's take this here and move this one to the other side. Okay, well, rotate. It's probably better to put it here because it has to. So now we have the components kind of laid out in a nice way, and now we can basically draw the circuit. And this is what I haven't prepared. So we're now on the front copper layer, and we're going to draw add tracks between the components here. So with this I can. So I think this is the track, and we can essentially connect this track, if I'm not mistaken. Yes. And now we've connected those, and this line disappears. And we can do the same for this. You can see where you have to go. We need to connect it to this one.
Can't it do that automatically? I mean, it seems like it's grind work, or am I missing something?
So when you do chip so the problem is when you do chip design, for example, real integrated circuits, you have to wire everything as well, and the more components you have, the more difficult it becomes. So in chip designs, you have a phase that's called place and route, and it's exactly the place all the components and route them together, and that's an NP-hard problem. So yeah, basically you use a set solver to try to solve this problem, and but for small components, it's probably doable, but yeah, for large problems, it's
manual.
yeah.
Or yeah.
Well, yeah. So and well, you have to connect this one, I guess, with ground here. So you could also take a layer on the back side of the circuit board and try to draw a line from there. Let me see. So this one then has to go, or could go there. So I think you can just draw underneath it then or something and connect to that. Well, I'm not sure about that. Guessed. Let me see. But let me just focus on only on the front. So we have to draw a line. What we can. So this is not going to be a very nice circuit, but just explaining the principles behind it. Now we have to connect this. Let me see if I have to connect more. So well, apparently we have to connect this and well, now it gets blue, so I think it's you cannot really cross this. So there is no way to really cross this, I think. So it doesn't work. So we have to fix this in our design, I think. So we pick it up. And we pick it up. Maybe delete this line. So
the M for move doesn't work now, or
no.
Oh, okay.
Maybe I should pick this too. That's probably better. Now I should probably delete this one, yes. And I can draw a line again from this one to that one. No. Why doesn't it work? Yes. By the way, you can also make your life a bit easier if by label the connections between the components in the schematic as well. So I think we're kind of done now with this thing. I think we can also verify this. It doesn't give us errors. Well, and now we have our little circuit board. That is, of course, not complete. And now we can we can export to SVG.
Yes.
And that can be imported in Inkscape, and then we can create it. But you can also plot it, and I think it will then choose some layers, and well, you can plot it to SVG as well, and that will be much more precise with really precise measurements. So I'll put the directory here. Yes. And you can generate a drill file as well.
Mm-hmm.
It's also something we need, I think.
Then we can use that in FlatCam to drill the holes.
Yeah. So, and this is, I haven't gone into this yet, but okay, we have a drill file now apparently. And I guess we can also plot now. Okay, so maybe let's try to look up because so how did I test project? Right, so Inkscape, Arduino, build. Let's see. Interesting.
Maybe do the
It's
copper.
drill file, I think.
Okay, do the CU, is that the copper? Does that make sense?
Yeah, I think so, yeah. So yeah, this might be the drill file, I think.
Mm-hmm.
Interesting.
The one I exported yesterday.
Yeah,
was
or
another
the
file.
silk, or the no, it's not called silk.
It's not the front.
This will be the front, I think. Well, if we can,
Yeah.
put this on a plate and etch it, that will be.
Oh, yeah, it says in silks, so the silks should have then the writing, like whatever, 220 ohms and so. You know what?
Oh yeah, I think so. Yeah, you can also write on the board and later. So the silks. What is that? Back. I don't know what is this.
Hard drive from, not back.
So this is empty. Yes.
You would have expected the ohms as well if they do it, but yeah. Anyway, you can probably customize it.
Yeah, I think
Any way you want.
I think you can print a legend or something. But
You could add that after it's etched. Put it in again and plot that on the board.
yeah.
Yeah.
You can do that before because else it's going to be etched also.
Yeah. So this is kind of my knowledge of KiCad.
There was plenty,
but
a mouthful.
But it's pretty powerful, as you can see.
Yeah, excellent. Yeah, very helpful.
Okay.
Excellent.